Right, hello, this is Foundation Lesson 19, Polygons and Angles in Parallel Lines. Now, polygons just means many, and gons, sides. So many-sided shapes. Okay, so we start with the smallest many-sided shape we can get, which is a triangle. Now, this is an equilateral triangle. And an equilateral triangle has three angles all exactly the same, equal, everything is equal, and this little line that goes across there means that the length of this and the length of the right hand side are the same. So when you see two lines, don't have to be parallel, they are the same length. Okay, there's another triangle called an isosceles triangle, where just two of the sides are the same. This one can be longer or shorter, and the bottom two angles are the same, and we get another kind, which is a right angled, and the only thing we know about that is that one is 90 degrees. There is another triangle called a scalene that sort of has nothing is the same, and you don't use these, they're no good to anybody. Nothing is the same. Not one angle, not two angles, not two sides, not three sides. Nothing is the same. Okay, so four-sided shapes. Four-sided shapes. So we've got four-sided shapes. Our first one, of course, is a square. Now a square has four right angles, and also all four sides are the same. Now the other thing about the square is that bit dodgy that, is that the top and the bottom are parallel to each other. So this is a parallel like railway lines, and you often see a little chevron on there. Now these two sides are parallel to each other as well, the left and right. So not to confuse them with the top and the bottom, I've put a double arrow there. Next one we've got is a rectangle. And the top and bottom are the same length, and they are also parallel to each other. These two are the same length, and they are also parallel to each other. It gets a bit messy with all these symbols all over the place. Okay, so, and these four-sided shapes are all called quadrilaterals. There's a special one here that's called the parallelogram. And the top and the bottom are parallel to each other, so we do that, and the sides are also parallel to each other. And just as in a regular rectangle, the sides and the top and bottom are the same length, we can have this one, a trapezium, and top and bottom are parallel to each other. Now they're not the same length, and these sides are also not parallel to each other, and they're not necessarily the same length, because you could have a trapezium that looks like that. So you know that definitely the left and right are not the same length. And these sorts of things, just knowing the names and the properties of them, help you find missing angles and missing sides. Now here is a kite, and the thing about a kite is these two angles are the same as each other, but the top and bottom are not. Now, perfect example with the kite is symmetry. Symmetry. This is a symmetry where, say if I took a heart and did my best, yeah, I can draw a line of symmetry down the middle. And a line of symmetry is always done with a dashed line, and what this means is that you can cut the shape in half and the left is a mirror image of the right. So when we had that kite, which is this, they've got long bits and short bits, you'd have a line of symmetry down the middle, and these two are the same, so the kite. And if we have an equilateral triangle, you'd have a line of symmetry there, a line of symmetry there, and a line of symmetry there. Now, because all three sides are the same, we call this a regular polygon. And the lines of symmetries on regular polygons match the number of sides. So if we do a square, we have a line of symmetry there, a line of symmetry there, another one going down the middle, another one going across the top. So you see we've got three sides, three lines of symmetry, four sides, four lines of symmetry, and this goes on for the different shapes. If we have a five-sided shape, providing all things are the same, the pentagon, this will have five lines of symmetry. So one, where are we going with this one? To the opposite side. It's two, I haven't drawn this very well, three, four, oh, let's draw, didn't quite match up because it didn't draw the shape very well in the first place. Let's do that again. Got no preformed shape, so we're just going to have to, that's a bit long, isn't it? Yeah, so this goes to the opposite side if it were drawn properly. How many we got there? We got five, yeah, five lines of symmetry. There is another kind of symmetry that we need to know about, and this is called rotational symmetry. And this is when you rotate a shape around the center, and every time the shape looks the same as the original, it's given a number of rotational symmetry. For example, you have the original of a rectangle. We call this number one. Yeah. And we spin it through, say, 90 degrees or whatever. It doesn't matter. You're slowly spinning it around a center point. That doesn't look the same as the other. Now if we spin it until it's upside down, then yes, that's the same as that, and then go round 3/4 of the way round and it looks like that. So that's the four positions, and it has a number two of rotational symmetry. Rotational symmetry equals 2 because it looks the same as each other twice. If we have a triangle, as long as it's an equilateral triangle, we can sort of spin it a third of the way around so that it still looks like that, and again like that, and again back to the beginning. So if I do a little mark on the bottom and call that shape number one, spin it round, the mark moves around there, so that's 2, spin it round, so that's 3, and spin it round again, so that's 4. So this doesn't really count because it is the actual middle. So if we ignore the one where we're back to where we started from, the triangle has 3 sides and it has a rotational symmetry equals 3. And this is the same. If you have a 10-sided shape, it will look like the original, including the original, 10 times. So now we're going to look at polygons in more depth. And so we're going to start ourselves off with a 6-sided shape, which is a hexagon. Now this is a regular hexagon, and all 6 sides, despite my bad drawing, all 6 sides are exactly the same. And for regular polygons, we might be asked to work out what's called the external angle, the internal angle, and the sum of all the internal angles. And there are several ways to do this, and we start with the first method. Right, what is the external angle? The external angle is this. And just extend each side to make an external angle, like this. Now, we've got 6 of them, yeah? Now, all the way around is 360 degrees. So to find the external angle, we would just do 360 divided by the 6 sides, all the 6 angles, which is 60 degrees. So we can put 60 degrees up there. Now the internal angle is this one. Now this is on a straight line now. And angles on a straight line add up to 180. So the internal angle will be 180 minus 60, which equals 120. And the sum of all the internal angles, we've got 1, 2, 3, 4, 5, 6, will just be 6 times 120, which is 720 degrees. So let's do exactly the same thing with a five-sided shape. 1, 2, 3, 4, 5. A regular pentagon. Okay, the external angle is this. There are 5 sides, so it's 360 divided by 5, which equals 72. The internal angle is this, which is 180 minus 72, which equals 108. And the sum of all the internal angles is 108 times 5, which is 540. So this works for everything. Yeah. Doesn't matter how many sides you've got. Now there's another method of doing this when you'll want to work out just the sum, because if you have a pentagon, yeah, and all the sides are different, it's called an irregular, and this goes to the same as all the other many-sided polygons, yeah. So you cannot work out the exterior angle because they're all different. You can't work out the interior angle because they are all different, but you can work out the sum, yeah? You can work out the sum of the interior angles by using this method. And this method will work whether it's regular or irregular. You take the number of sides and you subtract 2, and you multiply that by 180. So the number of sides is 5. If I subtract 2, I've got 3. And 3 times 180 is 3 18s is 540. As above. Yeah? So always. So if I took a 6-sided shape, 1, 2, 3, 4, 5, 6, I would do n minus 2 times 180, which is 6 minus 2, which is 4 times 180, 720. 720. Always works, right? So you could get a question where it says, oh, what about the sum of the interior angles of a 15-sided shape, 15-sided polygon? Okay, so you're going to do n minus 2 times 180, so you don't even need to draw this now. So it's 15 minus 2 is 13 times 180. I can't do that in my head, so I'm going to use a calculator. 13 times 180 is a fantastic 2340. 2340 degrees. So you can do that for any many-sided shape. Now, why is this working? Why is this working? So let's go back to the six-sided shape. So we know the answer is 720. So why is this n minus 2? How does that work? So if I go back to the six-sided shape there, more or less six-sided shape, yeah? And we want to do the sum of the interior angles. Now remember, our little formula was n minus 2 times 180. There is another way. What we can do is we can start at a corner and draw to that to make a triangle. Then we draw that one to make a triangle. It always come from the same place and make a triangle there. So our six-sided shape, we ended up with 4 triangles. And as you know, a triangle, the sum of the interior angles on a triangle is 180, 180, 180. So this is 4 times 180. Yeah, and look at this. 6 minus 2 is also 4 times 180. So you can divide a shape up into triangles. 4 times 180 is 36720. Yep, 720. And you could do this for a regular or an irregular shape. So you could do, don't know how many sides this is going to be, we'll just say 1, 2, 3, 4, 5, 6, 7. Right? So 1 triangle, 2 triangles, 3 triangles, and 4 and 5 triangles. So it's just 5 times 180, which is 1,800. 900. Yeah, 900. Yeah, so the sum of the interior angles is 900. Okay, so now the second part of this lesson was to do with parallel lines. Parallel lines. Okay, parallel lines. So now, there are several things to know to recognize properties of, so we can work out missing angles. That's what this is all about, missing angles. Know that all the way around a central point is 360 degrees. Also know that angles that make up on a straight line, together they will add to be 180. So angles on a straight line add to 180. So here we can see already that if we knew 2 of those, we could work out the third. Now, the next one is this, when we draw a cross shape. And these angles are the same as each other. And also, these angles are the same as each other, regardless of whether, if you imagine a pair of scissors and you're opening them up, yeah, it doesn't matter how wide or come back, how wide or how small they will always, the opposite angles will be the same, and these are called vertically opposite angles are the same. All right, let's go back to black, back to black. Right, now, so if we have a shape like this, where we have that, and we say that that is 40 degrees, this one is also 40 degrees because it's vertically opposite. And this one here, that one there, plus the 40 are angles on a straight line. So that one there, I'll call it X. 180 minus 40 equals 140. So that will be X. And this one here is going to be the same as x, either because you can do straight line ones, or you can do vertical opposite. So this one's going to be 140 as well. And 140 and 140 is 280, and another 80 is 360. So all the way round, they're 360. So if you knew one of them, you could actually find out what all the rest are. Now this followed through that we get two parallel lines, and there's a little angle chevron thing, and we get a line like this. So this is 40, right? Now this sort of junction down here is exactly the same as this junction up here. So from the 40 we can find the four angles that go round that junction, and these four angles are also exactly the same. So this becomes 40, and when they are in the same place on this junction as in this one, they are called corresponding. Now it may be corresponding. It may be that you're given one of these shapes and it says x is 40. What's the proof that y is 40, or why is y 40? Yeah, it's 40 because it's corresponding to x. So if you want to go a bit further with this one, you can say, oh yeah, I know, yeah, so that one's 40 as well, so this one must be 40 as well, because this one and this one are corresponding because they're in the same place. And then we've got the angle on a straight line, so that was 140. Vertically opposite, that's 140. Now you've got some more corresponding angles that make that 140. So you can see the top and the bottom is exactly the same. Right, so a corresponding, another one, another rule to remember to help you find all these different angles. So we've got there, and we've got, this is 140, yeah, we know that from above. And we also know that this is 140. Yeah. Now these are what we call alternate angles. Now the good thing about finding missing angles in these sorts of parallel line problems is that there is more than one way to work your way around the shape. Don't worry if the angle that you're after is a long way away from the original. Just go, oh, that's 140, so that must be 40, and that must be a corresponding up there, so that's a 40, and then 140 and 140 on a straight line makes 180. So you can find it that way, or you could go, that's a corresponding angle up there, and that's a vertically opposite one there. So you can get to 140 that way. So there's lots of different ways to get to it. Now, this one and this one, you may notice in this one above that you've got 140 there, and this one's 40. And you see that 140 and 40 make, they do indeed, 140 plus 40 equals 180. And this is called allied. So another reason how to get to angles within parallel lines are allied angles. So let's have a go so we can find some within some shapes. So we do parallel lines, of course, and we'll have a shape come here, and we'll have a line go up there. So they're supposed to be straight. So if we're given, what are we given? Let's say we're given that as 70, and we're given that as 120. Let's try and find X and Y and Z, that one down at the bottom. Okay, now, and we'll, not only will we find them, but we'll say why this is that. So we'll call that A. So A equals X, and that doesn't get anywhere, does it? So first of all, let's go back a step. A equals 60 because 180 minus 120 equals 60, and that is angles on a straight line. Yep, so now we've got 60 in there, and now I can do A equals X, which equals 60, and this is alternate. Good. Now, what about this Y? So we'll call that B. So B equals 70 because it's, can you remember? It's an alternate angle. Exactly the same as the X and the A. So B equals 70 because it's alternate again. Now, so we got that 70, and Y will equal 180 minus 70, which equals 110, and that is straight line again. Okay, now let's see if we can find Z. Do this in a different colour so we can see it's the second part of the same question. So Z. So what we're going to do, we know that all the angles in a triangle add to 180. So AB, we haven't got AB, so we have C in there. So C equals 70 because it's vertically opposite. Brilliant, yes. And D equals X. Now what was X? X was 60. D equals 60 also because it's vertically opposite. Now I'm going to expand that little triangle at the bottom there. So I've got this, that's that bottom bit, and C is 70 and D is 60. So we got to find Z down there, and we know that if we do 360 minus the sum of these two, which is 130, we will end up with, what will we end up with? 360. Where did I get that from? Be far too big. 180 minus 30 is 50, and the reason for that is angles in the triangle add to 180, not 360 as I wrote down just now. Okay, now just one other that always is a bit difficult to spot and difficult to remember is this one, but we've done it with the polygons, haven't we? Right here, this is an external angle, yeah, and if I make this external angle 100 degrees, yeah, just say, I don't know whether it's going to be, yeah, then this one, because it's angles on a straight line, I'll call that X. So X equals 180 minus 100, which equals 80, right? So that equals 80. So now what else can we do with this? And there, make it an isosceles triangle. Therefore, Y equals 80 as well, because these are the same as each other. So this one up here, Z, will be 180 minus the two lots of 80, which is minus 160. Sorry about that little dot. Yeah, which equals 20. So Z equals 20. All right, now one thing that happens here is that Y was 80 degrees and Z is 20 degrees. Now if you add these two together, they equal the external angle. So the external angle always equals the sum of the two opposite ones. Okay, and that is that. So that's filled in that little lesson 19. So see you in the next one.